10.6. Polar equations of conics. All right, so we got things happening in conics. We got a directrix, right? We got all the points along the curve in that plane that define either being a hyperbola, ellipse, or parabola, right? So let's do this. Let D, capital D, denote a fixed line called the directrix. We saw that already. And let F denote a fixed point called focus. So with that directrix and focus, we can put a string in and make the picture of either one type of conic, right? And then we're going to let little e be a fixed positive number called the eccentricity. The ratio of the distance from F to P to the distance from D to P. Okay, so some point on the plane. So a conic is a set of points P. In a plane for which the ratio of the distance from F to P and D to P equals the eccentricity E. All right, so ratio is a fraction, right? One number compared to another number. So mathematical notation, we can say the distance from F to P over the distance of D to P is equal to E. And I can go back and pull all the pictures of the parabolas that I've drawn with the focus and the directrix drawn. We do the same thing with we didn't draw the directrix on the ellipse, but we can do that. We can draw the directrix on the hyperbola, and we can do that as well. And it will still create all of the points that define the graph for that particular conic. But you already know one of them. If E equals 1, what type of conic do you have? You got a 1 out of 3 guess. Parabola, ellipse, or hyperbola? Think about the directrix on a parabola. The distance from the focus to a point was the same distance as the point to the directrix, right? So if those are exactly the same, that means same number on the top or the same number on the bottom. That's the eccentricity is 1 for a parabola. Okay, so I can look at an equation of a conic in polar form and just look at it and say, hey, that's going to be a parabola, just based on the eccentricity. And we'll define where E is in that equation, and it's pretty simple to see. If E is less than 1, the conic is an ellipse. And then you can draw that picture too, and you can see it. You got a focus is here, and your directrix is somewhere way outside, either to the left or to the right. And then when you see that the distances from here to a point is much larger than the distance from the point to the focus. So a smaller number on the top over a larger number on the bottom would create an ellipse. And last, everybody should get this one. If it's bigger than 1, the conic is a what? Hyperbola. All right, to calculate E. E is equal to, well, we already know the distance. I'm not going to do the distance formulas for all this. I don't need to do all that, right? But we know something about distance measures on all of these conics, right? I have the distance C. C is the distance from the center to the focus, divided by this distance from the center to the vertex. Okay. So just C over A. And so really nothing too new, right? We already know A and C. Just to find their ratios, and now you have E. The polar equation in conic form. So the polar equation. Now remember, polar equations involve r's and thetas, right? You got r as the distance from the pole to a point on the terminal side of that angle. And then we've got angles in terms of theta. So of a conic with focus at the pole and directrix perpendicular to the polar axis at a distance of P to the left of the pole is R is equal to E times P over 1 minus E times the cosine of theta. So we'll be able to find the value of E and the value of P. And then if we know those values, we can determine what type of conic we have and where are we located in reference to the pole. Perpendicular to the polar axis, which is the x-axis, right? Polar axis is the x-axis. Perpendicular is coming straight through vertically to it, right? At a distance of p units to the left of the pole. Right. Now we're going to change up this format. The bottom can be 1 minus e cosine theta. Okay, so that means you're to the left. If I do 1 plus e cosine theta, now we're to the right of the pole. And now if we do 1 minus e sine theta, we're that many units below the pole. And then if we do 1 plus sine, we're above the pole. So we got 4 different options. We'll put them all together later and analyze what type of conic we have. So if I have this, analyze and graph the equation. R is equal to 16 divided by 4 minus the cosine of theta. All right, so it's not in the format that we need. Now, obviously, you can go straight into the graphing calculator, put your calculator in polar form, and you'll know exactly what kind of conic we're dealing with if we get on the right. There we go, polar. So if I just do 16 divided by parentheses 4 minus cosine of theta, and then hit graph, see an ellipse, right? So then you can tell I'm in what mode I'm in, radian. Keep your mode in radians right now. You can see everything pretty good for a polar equation. So I know it's an ellipse, but what if I ask you what is specifically the eccentricity? We know it's got to be less than 1 to be an ellipse, right? So we expect that to happen. Well, I look at this format, it says E cosine theta, okay? So it says E, was that going to be a 1? No, it always must lead with 1 minus E. Okay, so I'm going to change this equation by saying R is equal to 16. I'm going to divide everything by 4 so that I get that leading term in the bottom to be a 1. 1/4. So now that simplifies to that 4 over 1 minus 1/4 cosine of theta. So there you go. You have 1/4 as your eccentricity. So E is equal to 1/4. That tells me this is less than 1. So we're dealing with an ellipse. I'm going to see how many units it is to the left of the pole. Is the directrix. All right, so I need to figure out what is P. Well, I know the numerator is EP, right? According to that format, EP divided by 1 over 1 minus E cosine. So if that's the case, we already have E. E is 1/4. The top is equal to 4. Therefore, I can solve for P. Multiply both sides by 4. P is 16, right? So the directrix is perpendicular in this case, 16 units to the left of the pole. Perpendicular to the polar axis. It's kind of hard to see on this because the directrix does not get graphed. You just see the equation of the ellipse. But if this is my pole right here, right, the origin, 16 units to the left would be way outside of this graph. There will be a directrix that would be vertical a vertical line. And my focus would still be right here at the pole. So it's putting the focus at the pole as well. So a lot of this section is not going to be a whole lot of actually arithmetic because they'll give you the equation. Just got to alter it slightly just to get it in that format. And then it's just really just looking at it and saying, okay, here's your E, here's your EP. That tells me the direction where the directrix is. Perpendicular, perhaps parallel, up above, or below, or left, or right. So let's see. And that's pretty much all I do ask for this section. I don't go into too much detail about you graphing it because I don't want you graphing that on my test. That's a mess, right? And so you can also just punch it in the graphing calculator, just like I just did there, if it is in a matching format on my math lab, which will be the same thing that they'll ask. All right, so here are all the different scenarios. Talked about 4 of them. R is equal to E P over 1 minus E cosine theta. Directrix. And then P units. Then we'll put the directions. All right, so if I talk about the directrix, if I see this equation, 1 minus E with a cosine that we just did this, the directrix is perpendicular, right, to the polar axis. P units left of the pole. EP over 1 plus E cosine theta. So you probably can figure this out. It's pretty easy just to kind of make the conjecture of what it's going to be next. It's still going to be perpendicular because we're dealing with cosine. Again, remember what the polar axis is. That's the x-axis, right? The positive x-axis. And then P units is going to be right of the pole. And if I change it up with the sine, 1 minus E sine of theta, this is no longer perpendicular to the polar axis. The directrix is going to be parallel to the polar axis. And this is going to be, if I have minus, what do you think? Above or below? Below. And then lastly, EP over 1 plus E sine theta. Still parallel to polar axis. And this would be, since it's plus, above the pole. Their eccentricities, if E equals 1, this is a parabola. in the axis of symmetry. This isn't all that important because, like I said, you can put this on a graphing calculator and see the equation, what its graph would be. Axis of symmetry is perpendicular to the directrix. If E is less than 1, we're dealing with an ellipse. And the major axis is perpendicular to the directrix. Okay, so the major axis is the long axis, the long part of the ellipse that it follows, right? So the directrix will be perpendicular somewhere outside of that. So, and then if E is greater than 1, we have a hyperbola. The transverse axis that's the axis that all the center, the vertex, and the foci all line up on. That's the transverse axis. That is perpendicular to the directrix. All right, so describe this one to me. R is equal to 3 over 1 plus, no, that's not right, sorry. Yeah, step ahead. 9 divided by 3 plus 3 sine theta. Need it to be that leading term in the denominator to be a 1, right? So I'm going to divide everything by 3, right? So I divide this by 3, this by 3, this by 3, and I am left with 3 in the top, 1 plus 1 sine theta, right? So therefore, we're looking at E. E equals 1. That's a parabola. EP is equal to 3. So if E is 1, E times P is 3, therefore P is 3. So we have a parabola. Where is the directrix of this parabola? Above, because we're looking at sine, the polar axis, right? Is it parallel, right, for sine? So we're 3 in their directrix is 3 units above the pole parallel to the x-axis. Now, parabolas are easier to graph than hyperbolas and stuff like that. You can easily tell where the directrix is going to be, because if you can see where the focus is, then the directrix is just totally opposite of it. That's many units away. So let's just put it in the graphing calculator. We've got 9 divided by 3 plus 3 sine. If there's a parabola, the directrix has to be, you can see the pole right here, right? So my focus is in here. So my directrix is outside of that. So it would be parallel to the x-axis, the pole, right? Above, so it makes sense. So just quickly graphing it, you can kind of verify that where it would be. So again, pluses are either going to be above or to the right. Above would be for sines, to the right for cosine. Minuses would be below, and those would be for cosines, or not below, to the left for cosine, right? All right, so that's pretty much all I do ask one test question for this one. So I give you one, you just tell me above or below, or left or right, how many units on the pole, parallel or perpendicular. Next, let's take a polar equation, change it to a rectangular. This is nothing new, we've done this before, right? So if you want to not have to worry about typing in a polar equation in the graphing calculator, you can transform it to its rectangular form. And that would be y equals, right? So let's do this. Convert a polar equation to rectangular form. R is equal to 1 divided by 2 minus 2 cosine theta. So just by looking at this, you might be able to figure out, well, what kind of equation are we expecting? This is a graph of a, if I divide everything by 2, this eccentricity would be 2 divided by 2, which is 1. So that tells us a parabola, right? So if we have a parabola, we know the equations of parabolas, right? Basic one, x squared equals 4ay, y squared equals 4ax, right? And then you can adjust those by x minus h and all those things. So one of the variables needs to be squared, the others to the first power, right? And let's see what we get. Obviously, you can put this in the calculator too and just see what the parabola is opening left, right, up, or down. Kind of can tell just from the properties we've already discovered. This is going to be directrix is going to be left. In this case, how many units? 1/2, whatever, however many units perpendicular to the polar axis, right? Right, so let's change this up. If I cross multiply and get rid of the fraction, right? So this will be equal to r gets multiplied to all of these, so I'll leave 2. We should try it. R times 2 minus 2 cosine theta would be equal to 1. If I distribute r across, 2r minus 2r cosine theta is equal to 1. Well, we know what r cosine theta is, right? So that conversion last test, how to go from polar to rectangular, rectangular to polar. R cosine theta, that is equal to x, right? So now we got 2r minus 2x is equal to 1. Let's put the minus 2x on the other side, so I'm just dealing with x's on one side, and then I'll be able to convert my r into something else. 2r is equal to 1 plus 2x. Now we have another formula for r, right? If I square both sides, that would make r squared, and I can replace r squared with something, right? So 2r all squared is 4r squared. And we'll go ahead and multiply all this out right here. Foiling this, 1 plus 2x times another 1 plus 2x. 1 times 1 is 1. Outer will be a 2x, inner will be another 2x. Totals of 4x, and last will be a 4x squared. R squared, we know, is Pythagorean theorem, right? X squared plus y squared. distribute across. Go ahead and put the x squared term first, and 4x, I guess it doesn't matter, but just make it in a standard form. 4x squared and 4x squared are the same quantity on both sides. I can eliminate them. So we're left with 4y squared is equal to 4x plus 1. All right, so there is a parabola, right? Opening probably to the right. I can keep on rewriting this equation in a different format that we're really familiar with. If I divide everything by 4, so divide everything by 4, this would be 1 x plus 1/4, something like that. I mean, it's as far as you can go right now, as far as according to the directions, that's a rectangular equation, x's and y's, right? So that's pretty good. So if you wanted to put this in the calculator, you would do y is equal to plus or minus x plus 1/4, right? So you see both halves or branches of that parabola. So if you see it starting off in this format, r is equal to EP over 1 minus e, cosine, sine, whatever one it is, just cross multiply. Okay. Any questions? That is the end of 10.6. Yeah. So it's very short and sweet section. Probably only 2 questions I would ask you from this section. Okay. Give me the characteristics of where the directrix is located, how many units, what type of conic, and then transform the equation to a rectangular one.